All right, in this lab, we are going to use a precipitation reaction to do some gravimetric analysis in order to determine the concentration of a solution. So this reaction we're going to be looking at is we have some aqueous calcium chloride that's right here. We have it measured out. I measured out exactly 25.0 milliliters of this solution. The concentration of this solution is unknown. We don't know what it is. But we're going to add some sodium carbonate, also aqueous, to this solution. And this is going to be in excess. So I've made this solution of sodium carbonate fairly concentrated. I'm going to add, relatively large amounts. So I'm going to have excess sodium carbonate. So let me measure that out. Okay. So here are my two solutions. Notice they're both clear, colorless liquids. This one I know the concentration of. I know it's in excess. This one is my unknown. And I'm going to mix them together, and I'm going to observe a precipitation reaction. Okay, so here we go. So I'm going to pour in my calcium chloride first. You can see again that it is a, colorless, transparent solution there. When I add, there you go. When I add my sodium carbonate, you see how it turns into this kind of opaque white mixture. So this is an example of a precipitation reaction. So we have now formed a solid. This solid that we have formed is calcium carbonate. And so what do we do now? Well, if we can purify and dry and weigh the solid, we could figure out how many grams of solid we produced in this reaction. And then we could do some stoichiometry and work our way backwards and figure out, well, if I made 1 gram of, solid product, how much calcium chloride must I have originally had in my original solution? So that's what we're going to do is we're going to weigh this solid and then do some stoichiometry to figure out how much calcium chloride we must have had in our original solution. So that's our goal, is to figure out the concentration of calcium chloride. And I mentioned the word earlier, gravimetric analysis. That's just a fancy word for I'm going to weigh some stuff. Okay, so I'm going to analyze this concentration by weighing versus like doing a titration or something. So we're just going to be using the scale here. So right now, this is a mixture. It's got some solid in it, but there's some other stuff in it as well. So in order to separate a mixture, if we have a mixture of solid and some liquids and solutions, we can filter them. Okay, so we're going to take a piece of filter paper, and we're actually going to weigh this filter paper first. So let's pause and record this piece of information in our data table here. So here's our balance. Hopefully you can see it. It is zeroed. And we are going to weigh this filter paper. So it looks like the filter paper is 1.06 grams. So this is information we'll need later. So you want to write that down in your data table. Okay. And then we're going to set up filtration apparatus. So filtration is a technique that's useful when you're separating a substance that is, not soluble in water with one that is soluble. So that's what we're going to use here because we've got a solid in there. And what I did is I folded my filter paper, I folded it in half, and I folded it in half once again. And then I kind of pop out one side, and this makes this nice little cone here that I'm going to stick in my funnel. So make sure we know the names of these things. This is an Erlenmeyer flask. This is a funnel. This is the filter paper. This right here is a beaker. Okay. So I'm going to filter this. Okay. And when I filter this, it might proceed kind of slowly. So I might pause the video here while I am filtering it. But what we are doing with this filtering process, again, is that we're going to end up with the solid stuck up here in the filter paper. And then down here, we should hopefully have just totally transparent liquid down here at the bottom, which will be the water and any other stuff that might have gotten through there. If this liquid down here at the bottom is cloudy, that's a bad sign because that means that some of my solid kind of escaped my filtration setup, and I would need to refilter it. All right, so I'm going to pause the video here while this filters. Okay, we are back and we have filtered most of our solid. Notice that the bottom looks nice and clear, so that's good. That means that all the solids stayed stuck up here and none of it made it through. Notice how our beaker, this is where everything was just a moment ago, is still kind of cloudy. That tells us that some solid is still remaining in the beaker. So important step here experimentally is we got to add some water and make sure we get everything out of the beaker. So we want to make sure we completely transfer everything there. And then what we're going to do next is we will have filtered this, which will have successfully separated the solid from the rest of the solution. So we'll have gotten a lot of the water out and also any other excess aqueous ions that are floating around in the solution. But my solid's still going to be pretty wet. So what we're going to do next is we are going to dry it in a drying oven to get rid of the extra water to make sure we can then collect just our pure solid precipitate. And that's what we're going to want to weigh. So I'm going to pause the video again, let this finish filtering, then we'll stick it in the drying oven. Okay, so what I've done now is I have taken the filter paper from my filtration apparatus and I've kind of spread it out a bit, and you can see it's still very wet. And I put it in this evaporating dish, which is something that's just okay to go in a hot container. And I put it over here in our drying oven. So here is my solid that is really stuck to the filter paper. And then I'm going to stick it in here and I'm going to let it dry for a while. And ideally, we would dry it and weigh it and then dry it again and weigh it again. So that's called heating to a constant mass. And that is the goal here. And you can see why we weighed the filter paper first. It's because that solid is stuck on the filter paper pretty good. So at the end, when we weigh it, we're going to have a mass of like the solid plus the filter paper stuck together. And then we're going to subtract the mass of the filter paper to figure out how much of the pure solid we made. So we'll come back to when it's dry and we will weigh the pure solid. All right, we can take a little peek inside the drying oven. You can see the volume of our solid has gone down a lot because we've gotten rid of so much water there, so it is drying along nicely. And then we will let it continue to dry and then we will cool it and weigh it. All right, so now we have dried our solid and now we're going to go over and we're going to weigh this again. And you might remember that our filter paper initially weighed about, I think it was 1.06 grams. So I'm going to zero my balance again and I'm going to weigh this. And it looks like now my filter paper plus solid is 2.67 grams. So it looks like I made about, 1.6 grams of solid. So we can do a calculation and figure out exactly how many grams of solid we made and figure out how many moles that is, and then do some stoichiometry to determine the concentration of our calcium chloride. All right, and then that is the goal of this lab, is to determine the concentration of the calcium chloride. Thanks for watching.